Hello everyone, this video is about finding rate law using the initial rate method. So as you can see in the chart over here, there's three methods for finding rate law. The first one is the initial rate method, which what this video is about, and I'm only going to focus on this method for this video. The other two methods are using integrated rate law, which you have to use the graph technique for finding the rate law, and then the third method is using the reaction mechanism and knowing the rate determining step. So I will tag my other two videos that shows how to find rate law using method number 2 and 3. But for now, this video is solely about the using initial rate method, which is method number 1. So for doing this, we have to look at some examples. So I have two examples prepared for you. So this is the first one. So they give us the reaction, and then what they do is that they want you to find the rate law for that reaction. So usually for these types of questions, they give you a table that has at least 3 experiments in it, where the concentration initial for both reactants are given to you, and then the initial rate is also given to you. So what we have to do is we have to find the rate law using this formula that rate equals to K times concentration of NH4 plus to the power of, we call it N, for example, and concentration of NO2 minus to the power of M. So what N and M are the orders of the reaction with respect to both NH4 plus and NO2 minus. So we basically have to figure out what N and M are. So for doing that, we have to have a strategy to use this table. So the strategy is to basically find the order of reaction for only one of the reactants first. And once you're done with that reactant, then you can move on and find the order of the reaction for the second reactant. So for doing that, what we have to look for is 2 experiments in which, for example, one of these reactants are constants. Their concentrations are always constant. So for example, if I look at experiment 1 and 2, I notice that the concentration of NO2 minus is not changing in these 2 experiments. However, the concentration of NH4 plus is changing. And my suggestion is for doing these, always go from the smaller number to the bigger number. So for NH4 plus, you can see 0.01 is smaller than 0.015. So see by how many times is NH4 plus being increased, the concentration of it is being increased. So as I can see, the concentration is becoming 1.5 times more. And because we put the N for the power of NH4 plus, so I'm going to put 1.5 to the power of N. And then I notice that NO2 minus is not changing, but then I'll see how does that affect my initial rate. And then as you can see, the initial rate is also increased by 1.5. So basically here we can see the concentration of NO2 minus is kept constant. So that's not the reactant that it's affecting our rate. So only by changing the concentration of NH4 plus by 1.5 times, we notice that the rate is increased by 1.5 times. So now we can solve for that equation, and we can say 1.5 to the power of N equals to 1.5. And this way we can solve for N, which is the order of reaction with respect to NH4 plus, and we see that is equal to 1. So now I know my N is basically 1. So we do the same thing now for the second reactant. So what we have to do is this time we have to keep the concentration of NH4 plus constant, and then see how changing the concentration of NO2 minus will affect our initial rate. So for doing that, I have to look at experiments 1 and 3 because that's the only time that NH4 plus is being constant. So as you can see from here to here, the NH4 plus is not changing. And as I was suggesting, it's better to always think about going from the smaller concentration to the larger concentration. So let's see, as I'm going from 0.01 to 0.02, the concentration of NO2 minus is increased by 2, and we put it to the power of M because that was the order of NO2 minus. So 2 to the power of M. And then I will see how is that affecting my initial rate. So basically, as you can see, NH4 plus is not changing. NO2 minus is going twice as more to the power of M. And then if I look at my rate, it's becoming actually 4 times more. So now I can solve for this equation and say 2 to the power of M equals to 4. Therefore, I know M should be 2. So the reaction is for NO2 minus, it's second order. So basically it's to the power of 2. So now I can conclude that my rate law is now K times concentration of NH4 plus to the power of 1, and then concentration of NO2 minus to the power of 2. And this is how we find the rate law for this reaction. So another type of thing they can ask in these questions is to figure out what the value of K, which is rate constant, is. So they can say find the value of K, which is the rate constant, and they usually ask for its units and its units. So for doing that, now it's pretty easy because we can technically take any of these experiments because we know the concentration of NH4 in that experiment. We know the concentration of NO2 minus in that experiment. We know the N and M right now, and we also know the initial rate. So by plugging in, we can actually solve for K. So for example, let's say we take experiment 1. So I can say that therefore K would be rate over concentration of NH4 plus to the power of 1 times concentration of NO2 minus to the power of 2. So I'm just substituting the information of experiment 1. So 0.02 over 0.01 to the power of 1, and then 0.02 to the power of 2. And this way we can find the K. So the K value would end up being 5,000 after you plug it in the calculator. So this is just finding the value. Now for finding the unit, my suggestion is exactly use the same formula for finding K, because I just separated K and isolated K, and I'm finding the K by dividing rate over these concentrations. So what I can do is now I can plug in the I can plug in the units, and this way I can find the unit for K. So the unit of initial rate is given to us, which is written as molarity times second minus 1 over, now concentration of NH4 plus is given to us in molarity times the concentration of NO2 minus is also molarity, but it is also to the power of 2. So after doing cancellations, I can see 1 molarity cancels with molarity. So therefore the unit of K would be, because m squared, molarity squared is in the denominator, I can bring it up and say it's molarity to the power of minus 2. And then second minus 1 was already up. So this would be the unit of rate constant. So I can say it's molarity minus 2, second minus 1. Okay, so this is basically the type of questions they can give you using the initial rate method and using the table provided to you. So let's take a look at another example. So in the second example, what we have is, again, they want us to figure out the order of reaction with respect to A and B. So for doing that, again, I have to start writing the rate law based on N and M and try to figure out what N and M are. So rate law would be K times A. We can again call it to the power of N, B to the power of M, and then we have to investigate to see what N and M are. So again, our strategy was to keep one of the concentrations constant, basically take 2 experiments that one of the concentrations remain constant while the other one is changing. For example, let's say from experiment 1 to 2, I can see the concentration of B is not changing, so it's just times 1. But if I go from the smaller one to the bigger one, I can see that the concentration of A is doubled. So if this is doubled to the power of N, and then this is staying the same, how does that affect my initial rate? And I can see already my initial rate is doubled as well. So then I can solve for this equation saying 2 to the power of N equals to 2. Therefore, I know N is 1, which is the order of reaction with respect to A. Now we do the same thing. This time we want to find the M, which is the order of reaction with respect to B. So this time we have to keep concentration of A constant. So a good way to do that is to look at experiments 1 and 3. And then we can see from going from experiment 3 to experiment 1, we can see that the concentration of B is doubling. So it's going to be 2 to the power of M this time, while this is not changing. And then we will see how is that affecting my rate. And as you can see, the rate is actually becoming 4 times more. So we can write down saying 2 to the power of M equals to 4. Therefore, we can say M equals to 2. And this way we can find the order of reaction for B. So now I can conclude that the rate law for this reaction equals to K times A to the power of 1 and then B to the power of 2. So this is how we find the rate law. Again, just for practice, let's find the K or the rate constant over here. So the rate constant can be found, again, as we said, by plugging in the values into any of the experiments. So let's say we can this time pick experiment 3. So in experiment 3, if I want to solve for K, I know K would be, again, rate over concentration of A to the power of 1, concentration of B to the power of 2. And then I'm plugging in the values for experiment 3. So K would be 0.40 over concentration of A is 4 to the power of 1 and then concentration of B, which is 3 to the power of 2. And then once we plug it in, we see that the value of K is 0.011. Now, for finding the units, we have to plug in the units of all the concentrations and initial rate as well. Just keep in mind, the reason I said we have to find the units is because the K unit will be different based on the order of reaction. So N is the order of reaction for A, and M is the order of reaction for B. So basically, we can say the overall order of the reaction, if they ask us, so overall order of the reaction is always the sum of N and M. So in this case, it's going to be 1 plus 2, which is 3. So for a third order reaction, the K unit will be very different than a second order reaction than a first order reaction. So keep that in mind. That's why every time we have to basically figure out what the unit is, because the unit of K keeps changing every time. So in this case, the unit would be found by plugging in all the information given to us. So for example, for initial rate, they say molarity over liter second. Just for making it easier, I say molarity over times liter minus 1, second minus 1. I'm basically taking the denominator to the numerator. So putting them as with a negative power over the concentration of A, which is moles, again, liter minus 1, times the concentration of B, but it has to be to the power of 2. So it's going to be moles squared, and then liter minus 2, basically. So now I try to cancel all the units. So as I can see, moles cancels, this and this cancels. So anything in the denominator now can come up, but the sign of the power has to be changed. So moles squared would become mole minus 2. Liter minus 2 in the denominator comes up as liter positive 2, and then times second minus 1. So basically, I can say the unit of my K is moles minus 2, liters 2, second minus 1. Okay, so that was it for this video. I hope you enjoyed it. If you did, please make sure to like it and subscribe for watching more videos. If you have any questions, make sure you leave it in the comment section. Have a good one.